All right, so hello, everybody. Thank you very much for joining us here. We are extremely excited to be here with you today. With me here is Nethanel Coppenhagen, and my name is Nimrod Stoler. We are both security researchers from CyberArk Labs, which is located in Israel. This session today is about the research we conducted on the Blue Prism robotic process automation platform. This research yielded 8 CVEs in different severities, ranging from medium to critical. And today we will be publicly disclosing for the first time 3 of these attack vectors, the full attack vectors, which yielded 3 of those CVEs. So today, in this session, we'll be talking about what RPA is, how Blue Prism is going into the picture, where all the secrets are. But first, we want to answer the question here on this first slide. And the question is, how do we know we can trust robots without secrets? How do we know if we see a robot? How do we know if the robot is trustworthy enough that we can trust it with our most guarded secrets? So in public, we can say that robots are either faultlessly loyal Victorian butlers or psychopathological killers. So we can take, for example, Isaac Asimov's positronic brain robots with their 3 laws of robotics. You have the 3 laws, well, a very short version of the 3 laws here on this slide. So these 3 laws of robotics are simply carefully engineered safeguards put in place by Asimov in order to prevent robots from harming humans. It was Asimov's way of creating ethical robots, robots that would not only protect human lives, but also human interests. So if we look into our 2 types, the loyal butler type and the psychopathological type, which one would be Isaac Asimov's robot? Can you help me here? Or it probably, yeah? Yeah, it'd probably be the first type, the loyal butler type. And we might just consider letting Isaac Asimov's robots in on our secrets. And what about HAL 9000? Was HAL a trusted robot? Would we trust HAL without secrets? So HAL 9000 is a sentient artificial intelligence computer that controls every aspect of the Discovery 1, which is on a mission to explore Jupiter and interacts with the human onboard crew, astronaut crew. So in the Space Odyssey, bad instructions given to HAL directly from the White House, believe it or not, caused HAL to kill the entire human crew for the conservation of the mission. So in this case, which type of robot would HAL be, or would HAL fit? So it would be the second type, so HAL is probably the psychopathological killer type, and no secrets for HAL. Anyone here recognizes these robots? Okay, maybe 3 or 4, great. So these are the Daleks, or the formidable Daleks, from Doctor Who, the British science fiction television program, broadcasted since 1963, with over 800 episodes today, and still broadcasting today. So as soon as the Dalek robots were created, they exterminated, as they like to say, their scientist creator, and it was due to his specific command to them, that they should become the strongest, most powerful in the universe. Well, according to the Daleks' logic, in order to become the most powerful in the universe, they must kill all those who are stronger. And of course, their creator is by definition stronger. So again, the Daleks are probably the second type, the psychopathological killer type, and no secrets to the Daleks. So if we try to answer the question, can we share our secrets with the robots, we can answer it by looking at their programming. After all, every robot is a computer, and computers use some kind of logical programming. So if we can somehow get a good, deep, thorough understanding of their software, we may be able to tell if we can trust robots, if robots are trustworthy enough, that we can share our most guarded secrets with. In cybersecurity, we call this process reverse engineering, or software reverse engineering. And this is what we did in our research, and this is what we're going to show you here. So we talked a little bit about robots, but we said that our research was on robotic process automation. So what's robotic process automation? Well, first things first, unfortunately, there are no real mechanical or electromechanical robots involved in robotic process automation. RPA is not about physical robots. It is a software technology that makes it easy to build, deploy, and manage software robots. Robots that emulate human actions while interacting with existing digital systems and software, most of which are Windows applications. Now, these interactions usually have some kind of a keyboard injections, key injections, or mouse clicks, and this is how the robots actually emulate how humans interact with those existing enterprise applications. So many industries are currently benefiting from RPA, from banking and finance, through healthcare and medical applications, human resource management, manufacturing, customer service, all with one common denominator, which is the extensive use of enterprise credentials. If we want robots to log in, access, and control those existing enterprise applications, we must place those credentials, secret passwords, in the hands of the robot. So we talked a little bit about what RPA is, and now we had to choose, in our research, we had to choose a target. So we looked a little bit about the market, and we found that there are 3 large vendors in the market. One of these was Blue Prism, which eventually we picked, and also Blue Prism was also named a leader in that market by both Forrester and Gartner. So it was an easy pick for us, and we just went online and downloaded their trial software from their website, which was just a full software, the full-fledged software with a trial license. So looking into the Blue Prism platform, we could see that it was based on the Microsoft .NET framework and written mainly in C#. And here we have the architecture. So the architecture of the Blue Prism platform is based on 4 components. First and foremost, and our prime target, is the application server, the Blue Prism application server. This is where all the magic occurs and where the logic behind the Blue Prism platform is stored and implemented. The application server is heavily relying on an MS SQL database server. This is where all the users, the configurations, the business processes are the code that eventually runs on the robots. And of course, all enterprise credentials are all stored in the database server. Now, the application server may be actively accessed by two components. So we have the interactive clients and the Blue Prism runtime resources. So interactive clients are the user's machines, the machines that are used by human users in order to set up, control, configure the entire platform. You may look at it as the graphic user interface, or maybe the terminals that are used to access the application server, and the application server itself is off limits to all users. The second here is the runtime resources. Well, these are the robots. These machines receive their commands or code directly from the application server. They would run that code, again, in order to log in, access, and control those external existing enterprise applications. And of course, at one point or another, we should have clear text credentials in those robots, in those runtime resources, and those credentials will be, again, transferred from the application server. So we're always interested in secrets and credentials, so how are these handled in the Blue Prism platform? So the Blue Prism is using asymmetric encryption in order to encrypt and decrypt critical data on their platform. That means that there is only a single key, one master key, that is used both to encrypt and decrypt that information. So this key will be stored on the application server's file system inside an object that we'll see in a minute that is called encryption scheme. So in the encryption schemes, we may have the name of the encryption scheme, the algorithm used, and of course, the key or the master key used. So this will be on the application server. The password and credentials, on the other hand, and all other critical information will be encrypted and stored on the database server. This makes sense because if somebody gets their hands on the database, they will only have encrypted information that they cannot use. And such an attacker would have to find a way to get those encryption scheme keys from the application server, and that's not easy.
So, after Nimrod talked about the component in Blue Prism platform, we need to talk a little bit about how those components communicate each other. The Blue Prism architecture is implemented using Microsoft Windows Communication Foundation, WCF. It is part of Microsoft .NET framework, and it makes the development of an endpoint easier and less time-consuming. Let's see how it's done in our case. So, as Nimrod said, we have the interactive clients and the runtime resources, which are WCF clients. We also have the application server, which called WCF service. Between them, we have a service contract that contains operation contract. The operation contract defines the parameters and the return type of the operation. In our case, the service contract is a C# interface, and its implementation is a class on the application server itself that implement all the methods, the operations. So when the WCF client calls the operation, the WCF framework takes the parameters and transform it into a transmittable format and send it over the network to the WCF service. Then the WCF framework on the WCF service, the application server, transforming back to the parameters, like a data object, .NET object, and calls the operation. And after it runs, the result transform again to a transmittable format and sent to the client. So, as Nimrod said, we managed to download the Blue Prism platform, and we looked inside. In our case, the WCF, the service contract, is an iServer interface. And those all the operations, there are many more. And the implementation of it is a CLS server. It's a class that implements the iServer. So when the client calls an operation, it basically uses it as a normal object instance of the iServer itself. And it calls it like a regular object and use its methods, and the WCF framework handle everything. So before we continue and dive into our attacks, we need to talk a little bit about .NET executables. .NET executables aren't like any other executable. They don't contain native binary code. They contain intermediate language called MSIL, Microsoft Intermediate Language. And when it's executed, there is a just-in-time compiler in the .NET framework that translates it into binary code that's executed by the CPU. And now we can talk about, and this is one of the features of the MSIL. It can be transformed back into source code very easily using a reflection tool called DNSPy or any other tools, and it can be debugged like step by step.
Okay, great. Thank you, Nethanel. So finally, we've reached our first attack, and here we will try to define our attack surface, and from there, see if we can try and steal those encryption master keys that we discussed before. So first, we started looking into the .NET application using DNSPy, which shows us the actual source code that Blue Prism developers see. And we soon found out that the application server, which is our prime target, was pretty well protected. However, it seems to us that the application server, to some extent, is willing to communicate with any WCF client on the domain. So that means that even unauthenticated WCF clients are able to call each and every one of the server, the WCF server, the application server's methods. And this now became strategically our attack surface. So our goal was now to somehow disguise ourselves as a WCF client on the network, on the domain, and try whatever whatever server methods we could in order to somehow make the application server misbehave. So let's first look at an example of such a method. So as I said, every unauthenticated client, WCF client on the domain can call create credentials if it knows the correct parameters it should provide. Now, this is the server side. So what the server is going to do, if a WCF client calls create credential, it will first execute check permissions here in red. Now, check permissions would check if the calling WCF client is indeed authenticated with Blue Prism, and if it is, it will load the secure method in yellow, secure method preamble, and compare the permissions of the client with whatever is written in the secure method. So if I'm a WCF client and I'm authenticated, then only if I have the permission security managed credentials, then check permissions would allow the continuation of the methods. In any other case, check permissions would return an exception and the execution will be stopped. Another example of a CLS server, class server method is this unsecured method. So we can find a number of cases where the server, the application server, should allow unauthenticated WCF clients to actually run code on the server. An example is, of course, the login method. So as we can see, the login method does not have a check permissions call, and the preamble is unsecured method. So this is another example. So we had to go over all of those dozens and dozens and dozens of methods, server-side methods, and trying to find the one that would make the application server misbehave. Well, after maybe 3 or 4 passes, we found this. OK, let's zoom in. So as you can see, this method is get encryption schemes. That's interesting because this is what we wanted. We can also see that it is in the wrong place. It is physically inside CLS server, but we can see that it belongs to iServer. So that's an anomaly. That's weird. Now, what get encryption scheme does is it gets the database connection, and it calls the local get encryption schemes with the connection and true. So we wanted to know what that true means. So if we dig into get encryption schemes here, we will see that the true is include key. And this true value will be transferred on, and eventually, get encryption schemes would not only return all the encryption schemes of the Blue Prism platform, but also include those master keys that we discussed earlier in that collection that is returned, this one. So the only question we have left is, can an unauthenticated client actually call this server-side function or method? So let's see a demo. So here, the attacker, we are user 1, and we are not a user in Blue Prism, so there's no way we can authenticate ourselves. We are user 1. So this is the code that we downloaded, the client code that we downloaded from Blue Prism. And we run it as it is. We just added a line there. You will see that in a minute. Now you can see that we are pre-login, so we are pre-authenticated. Login is only after us. We added this line, the server get encryption schemes, and try to call it. So again, we may get an exception, but of course, no, we received 2 encryption schemes. Again, we are an unauthenticated WCF client. Let's look into the first encryption scheme here. So this is the default encryption scheme, the one that is used to encrypt and decrypt all credentials on the system. And we're going to test the key here if it actually decrypts credentials from the database. So we're going to copy the key that we received. That's the key. We're just going to copy it. And we've written a small application that attempts to decrypt using the key. It's an AES key, and the credential we copied from the database. And wow, this is a secret. So our attack was successful, and we got the correct master key. So that's great. So we have the master keys in our hand. But coming to think of it, it's like having half of a treasure map. And we probably won't be able to find the treasure without the other half being the encrypted credentials. So we started thinking about how we can chain other attacks with this attack that steals the master keys. And then we thought, well, where are those encrypted credentials stored? They're stored in the MS SQL database. So why not run an SQL injection on it?
SQL injections. SQL injections are one of the most known, oldest, and dangerous attacks known. SQL injection is an attack where malicious code inserted into a string and then passed to a database for execution. There are known ways to prevent SQL injection is to use very strict input validation and also use parameterized queries. The Blue Prism platform used those rules religiously. And we went through the code several times, all of it, and we didn't find any point where we can actually inject SQL. So this is why we went to the stored procedures. Stored procedures are a set of SQL statements that are stored in the database and then can be reused and shared between applications. It also allows the developers use pre-written queries that already approved. There is another security aspect here. It allows accessing part of a table without direct access to the table itself. This is a partial list of the Blue Prism stored procedures. We went through all of them, and we didn't find even there any point we can actually inject code. But then we found the system stored procedure in red. This folder contains default stored procedures that come with the MS SQL installation by default. So we went in there and we found this stored procedure, SPSQL_exec. It receives a string through the parameter P1 and then executes it. The only question now, can we call this stored procedure through the Blue Prism application? So we went through the code again, and we found this method, GetChartData. It's a secured method, so we need to be a user in the Blue Prism platform, but we don't need any special permissions. We can be any user in the system. Inside, it receives data source name, which is the stored procedure name, and the dictionary param. Then it connects to the database and calls the local method, this GetChartData. And inside, it calls the stored procedure using the params dictionary. Let's see how we can use it. So we are in the Blue Prism interactive client, and as you will see in a few seconds, we are a user in the system, but without any roles or permissions. So we can be any user in the platform. On our attacking server, we have HTTP server that will save PowerShell code, and we have reverse shell netcat in listening mode. This is the MS SQL server. As you can see, the IP address ends with 148. And yeah, so this is our patched client. We run it and we call the GetChartData method. And we call the SPSQL_exec and use a P1 parameter with our payload. Our payload will request in HTTP the PowerShell right here. It will request the PowerShell script, a PowerCat. It's an implementation of netcat in PowerShell. And then it will execute it and connect to our reverse shell. And here we have basically a reverse shell with anti-authority system on the SQL server itself. Thank you. Thank you. So, some conclusion for this attack. First of all, as you can see, SQL injections are very impactful. In our case, we have access to all encrypted credentials. And with the attack that Nimrod just showed us, we can basically decrypt them. So great, we have credentials. We also have code execution on the robot, the runtime resources, because their codes, the process codes, are stored in the database. And also, we have elevated remote code execution on the MS SQL server. Now, we are going to our third attack, our last attack. In this attack, our target is to access the heart of the Blue Prism platform, the application server itself, and we're going to use insecure deserialization. For those of you who never heard about insecure deserialization, we can take, for example, Equifax, that at 2017, they announced that over 143 million personal data of their customers has been compromised. This was due to an insecure Java deserialization that allowed to run code on their server. Let's see how it's done in our case. So, as we said before, we have our clients, our interactive clients and runtime resources. And we have the application server. The client, the WCF client, is calling an operation, and the WCF framework transforms it into a transmittable format. In our case, a SOAP XML. This transformation called serialization. Then it's sent over the network, and on the application server itself, the WCF framework there transforms it back into data object. This is deserialization. In our case, we have those clients, but we have a compromised client. And when the client calls the operation, the WCF framework transforms it, serialize it into SOAP XML, but then the attacker injects his own payload to this XML. Then it's sent over the network, and the WCF framework deserializes the malicious payload to and pass it to the application server. But this deserialization happens before we even run the application server code itself. So we don't need any permissions to do this. Now, when we are talking about serialization, we need to talk about serialization engines, serializers. In WCF, there are two majors. One, data contract serializer and net data contract serializer. The net data contract serializer includes object type information in its SOAP XML, and this is why it's more permissive. So we went through the code, and we found several methods that use net data contract serializer. This will be our attack surface. Next, we need to find a point where we can actually inject our payload, and it will be serialized without any errors. So we scanned those methods that use net data contract serializers, and we found that some of them use the type session runner schedule. This type is very interesting because inside it, it has an attribute, abort lock, that is an object type, which means it acts like a wildcard and can be any object we want. So when a client calls one of those methods using session runner schedule, it looked like this basically on the wire. This is how the SOAP XML look like. It's very big, so those are fragments. We have the header and we have the body of the SOAP XML, and inside we have the data for the operation. And inside we have the session runner schedule, and the mabort lock, and here we want to inject our payload. Let's see how it's done.
Okay, great. So this is our demo for the deserialization attack. Now again, we are completely unauthenticated. In this case, as Nethanel explained, everything happens a lot of time before the Blue Prism application server even gets control. So this is our application server at user 6. And we're going to show that we cannot be authenticated. We are not a user. Again, user 1 is not a user on the Blue Prism platform. This is the scheduler create schedule method that we're about to use. And as Nethanel explained, we will be injecting our malicious payload inside this class here, the session runner schedule, and we're going to use the object mabort lock. So this is the code that we're injecting, and again, we're unauthenticated. We're just creating the session runner schedule and calling scheduler create schedule. And after it will be serialized by the WCF client. Okay, this is the, again, we've seen this. This is the attacker command and control, both sides. So once the WCF client serializes that information, this small application of ours is going to intercept that SOAP XML byte data and replace mabort lock with our malicious payload. This is the SOAP XML data. We have the header and the header, whatever. And here, the application server at 1:45 requested the PowerCat script. And we have a reverse shell on user 6 and over the application server. And since the application server is running elevated, we are also admin. We are running in the context of an admin inside the application server. And again, we are completely unauthenticated WCF client on the domain. So final conclusions and mitigations. So about 4 months ago, CyberArk Labs did a full disclosure of 15 attack vectors, that's it, that we discovered and communicated to Blue Prism. Since then, we have been in continuous contact with the Blue Prism security and technical teams, and in collaboration to fix the reported attacks and release software patches to customers. As we've seen, RPA is indeed very sensitive. Human operators have MFA, multi-factor authentication. They can change their own password when they are instructed to, and they are less predictable than software robots. Robots, on the other hand, are one-dimensional as far as their identities are concerned, with no real possibility for multi-factor authentication. This makes them more susceptible, a lot more susceptible, to attacks such as the ones we've shown here. Another point that we would like to mention here, and Nethanel talked about it a little bit, is that RPA application server practically runs code on the robots. By taking over the database or the application server, an attacker gains complete control over the robots and all credentials used by the robots. Credentials are downloaded in clear text to the robots. So if robots are the puppets, the application server is the puppeteer. So due to all we said above, enterprises should take recommended vendor practices as a must and be sure to deeply and thoroughly understand the security implications if recommended practices are not followed. Because of the sensitivity, we should always use defenses in depth. This may be the difference between a successful attack and a failed one. So For example, we should use network monitors wherever possible. We should use endpoint protections, such as EDRs, XDRs, and of course, protect credentials by placing them as much as possible in external credentials vaults. Questions? Yeah.
Do you think do you think moving to certificates would be at least one step forward? So then we can cryptographically authenticate both the client and the server versus passing credentials around.
Can you repeat the question a bit
Would
louder?
When moving to certificate-based authentication, so we can cryptographically authenticate both clients and servers, do you think that would move something forward versus passing credentials around?
I think these are two different issues. Blue Prism is already using certificate-based authentication with TLS on both client and server, but it didn't stop us here because the application server was willing to accept us as a WCF client anyway. The only issue here was with the encryption schemes used to encrypt critical data on the application. So I think these are two different things.
I think it's an architecture issue.
It may be.
Yeah.
Oh.
Can you pull up that server code block where it runs the deserialized payload again? I'll hide that up pretty briefly.
Sorry, come again? Where?
Pull up the block of server code that was running the deserialized payload.
The block of the...
This one?
No, the server side code that runs the deserialized payload.
The server side. You mean this interface?
Yeah, the actual listener, the receiver method.
So the listener receiving it is in the WCF framework. It's not part of the code of the application server itself. It's before that with .NET DLLs. This is where the serialization happened and the deserialization.
Let me try to make it a little bit clearer here. The thing is, the Blue Prism application server is expecting to receive parameters. It's expecting to receive string name or the session runner schedule, right, as a parameter. Now, the entity that is in charge of providing this parameter is the deserializer. So deserialization happens before even the Blue Prism code starts running.
Okay, thank you.
Okay, great.
Is there a specific requirement where the Blue Prism application server and the database server was running as system? Because that seems to be an issue as well.
It may be. The database server was indeed running as a system, but it may be an issue. But in any case, the fact that we managed to get SQL injection and remote code execution on the MS SQL server means at least that we have access to all the credentials. Because with the SQL injection, we can do other things rather than remote code execution. We just thought remote code execution was the nicest thing we can do. But the idea is that if we have SQL injection, we can extract all the encrypted credentials and then decrypt them using the master keys that we stole in the tech one. So that was the idea.
We've got about 10 minutes left. Are there any other questions?
Have you guys looked at other RPA tools? Blue Prism obviously is one of the big ones, but have you looked at any of the other ones? Or?
No. We had a mandate for one, but we may be in the future. I'm not sure.
Hello, Nimrod. I'm probably throwing myself under a bus here, but there is representation from Blue Prism here, so if any guys want to have a chat with us afterwards, we're here, and we're more than happy to have a chat with you. And just a quick note to Nethanel and Nimrod, it's been a pleasure. There was some stuff that came out of it, but we've worked together, and it's been great.
Same here.
Thank you very much.
Great.
I was just interested in the payload that was used to get through the deserializer. Yeah.
Yeah, that's a good question. Internet?
So the payload is basically a payload in data of net data contract serializer. You can use it for with like YSOSerial.net, but you need to customize it a little bit because it's not a complete SOAP XML like the YSOSerial, for example, give you. You need to a little bit play with it to build it, but it's a basic payload. It's not like any complicated one.
Thank you very much, gentlemen.
Hey, thank you very much.
Thank you.